Lesson 29, I will estimate sums and differences using benchmark numbers. So today we're going to be talking about estimating. So in your math journal, I want you to go ahead and write today's date, Lesson 29, estimate sums and differences, and then we're going to talk about what this means. All right, so hopefully you got your math journal ready, and let's think about this for just a minute. The first thing I want you to think about is, what does it mean when I say make an estimate? If I say estimate about how much time you need, well, I'm wanting you to make a guess about how much time you need. Well, when you are estimating something, it's when you're kind of rounding what you're talking about to the nearest time. If I'm talking about time, if I'm talking about fractions, you might estimate to the nearest whole number. If I'm talking about whole numbers, you might estimate to the nearest tens, to the nearest hundreds. So let's start with this estimation. Let's estimate a sum. Let's estimate 3 1/5 and 4 8/9. I want you to write this two mixed numbers in your math journal. And I want to make sure that you have the word estimate close to it so that you know that that's what we're doing. All right, the next thing I want you to do is I want you to draw a number line. So on your number line, we are going to start our number line with the whole number 3, because we're talking about 3 1/5, and we're going to end with the whole number 5. So let's go ahead and put 4 in the middle here. So we've got 3, 4, and 5. So let's start by thinking, where would 3 1/5 come on this number line? Well, it's going to come between 3 and 4. Is it going to be closer to 4, or is it going to be closer to 3? Well, if I divided this into fifths, which I'm not going to, but let's pretend I did, the very first fifth would be 3 1/5. So here's 3 1/5. What about 4 8/9? Where would it come on the number line? Would it come between 3 and 4, or would it come between 4 and 5? Well, it would come between 4 and 5. Where would it be? Would it be closer to 4, or would it be closer to 5? Well, if I divided this line into 9 parts, and I went with 8/9, 8/9 would be all the way down here because it's almost 5. It's almost 9/9. So 4 8/9 would be all the way down here. So if I'm going to estimate these numbers, and I want to say, well, is 3 1/5 closer to 3, or is it closer to 4? Well, it's closer to 3. Is 4 8/9 closer to 4, or is it closer to 5? Well, it's closer to 5. So now I can estimate my sum. I can round 3 1/5 to 3. I can round 4 8/9 to 5. Now I want you to write this number sentence in your math journal. 3 plus 5 equals 8. Okay, so we estimated 3 1/5 plus 4 8/9 is 8. Okay, so let's think about this for a minute. What if we wanted to estimate the difference? So go ahead and copy this math problem in your math journal. We don't have to create a new number line because we've already done this before. We know that 4 8/9 is closer to 5. We know 3 1/5 is closer to 3. So when we estimate the difference, we have 5 minus 3, which is 2. Now let's think about this for a second. If you wanted to know the actual difference, not the estimated difference, we estimate the difference to be 2, but if you want to know the actual difference, would it be a little bit more than 2 or a little bit less than 2? Because it's not exactly 2 because we estimated to find that number. Think about that for a minute. Well, here's a good way to think about this question. We're actually estimating this distance. This is the distance that we're really talking about. Kind of hard to see that yellow. Let's try something different. We want to know how far it is from 3 1/5 to 4 8/9. This is the actual difference. But we estimated the difference to be this. So the actual distance is less than 2 because you can see on this number line that the distance between the real numbers is shorter than the distance from 5 to 3. So the actual difference would be less than 2. Okay? All right, so let's practice this a little bit on our problem set. Go ahead and write your name on your problem set, and let's take a look at the directions. Estimate each sum or difference to the nearest whole or half by rounding. Explain your estimate using words or a number line. Okay? All right, so we can use words. We can also use a number line. I think I would like to go ahead and start by using a number line. So let's start right here. And we've got 2 and 1/12 plus 1 and 7/8. So let's go ahead and do 1, and we'll do 2, and we'll do 3 on our number line. All right, so let's start with 2 and 1/12. Would 2 and 1/12 come between 1 and 2, or would it come between 2 and 3? Well, it would come between 2 and 3. So if I divided this number line into 12 parts, which I'm not going to, but they would be pretty small, and if I had 2 and 1/12, it's going to be pretty close to this 2. So I'm going to go ahead and label this 2 and 1/12. Now let's think about 1 and 7/8. Would that come between 1 and 2, or 2 and 3? Well, it would come between 1 and 2. So if I divided this number line into 8 parts and I had counted over 7/8, 1, 2, 3, 4, 5, 6, 7, I would end up way down here with 1 and 7/8. It's only 1/8 away from being 2. So if I'm going to estimate 1 and 7/8 to the nearest whole number, I would say it's closest to 2. If I was going to estimate 2 and 1/12, I would say it's closest to 2. So I'm basically saying 2 plus 2, which is 4. So 2 and 1/12 plus 1 and 7/8 is about 4. All right, let's try another one. All right, so now I've got 1 and 11/12 and 5 and 3/4. So let's go ahead and do another number line here. Now remember, you could choose to use words. I'm just choosing to do a number line. I'm going to start with 1, and I'm going to go all the way to 6. So then I'm going to have 2, 3, 4, and 5 in between. 2, 3, 4, and 5. So let's start with 1 and 11/12. Would 1 and 11/12, where would that come on the number line? Well, it would come between 1 and 2. And we have 11/12. So that means if I divided this into 12 parts, I would go all the way over until I got to 11/12. That's going to be way down here. So I've got 1 and 11/12, because 1 and 12/12 is the same as 2, so it's almost 2. All right, so what about 5 and 3/4? Where would it come on this number line? It would come between 5 and 6. And if I divided this into 4 parts, 5 and 3/4 would be down here, because we would have 1/4, 2/4, 3/4. So I've got 5 and 3/4. So 1 and 11/12 is about 2, and 5 and 3/4 is about 6. So I've got 2 plus 6, which is 8. All right, let's try one more. Then I'm going to let you practice a little bit by yourself. All right, so let's try our number line again. Same thing, except this time we're subtracting. So I'm going to start with 2, and I'm going to end with 9. All right, so I've got 3, 4, 5, 6, 7, 8. So let's go back and label these. 3, 4, 5, 6, 7, and 8. So I want you to pause the video for a minute, and I want you to just put 8 and 7/8 on this number line and 2 and 1/9 on this number line, and then let's come back and just see if we have them close to the same place. So go ahead and pause the video now, and I want you to label 8 and 7/8 and 2 and 1/9 on the number line. Okay, so hopefully you went ahead and tried this by yourself. 8 and 7/8 is going to come between 8 and 9. So if I divided this into 8 parts and I counted over 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 7/8 is going to be all the way down here, because 8 and 8/8 equals 9. So 8 and 7/8 is really close to 9. And then I'm going to do 2 and 1/9. Well, 2 and 1/9 is going to come between 2 and 3. And if I divide this into 9 parts, the parts are going to be pretty small, and the very first part is going to be 1/9. So I've got 2 and 1/9. So 2 and 1/9 is about 2, and 8 and 7/8 is about 9. So I've got 9 minus 2, which is 7. All right, let's try 2 more. Okay? Now, if you're feeling really brave, go ahead and pause the video and see if you can't do the number line and everything all by yourself. If you're not feeling quite that brave, go ahead and stay with me while we do the number line, and maybe you'll feel brave enough to do it after we get the number line drawn. All right, so let's start with the number 2, and we're going to go all the way to 7 on our number line. So we're going to come back and we're going to say 3, 4, 5, and 6. 3, 4, 5, and 6. So if you think you can go ahead and do the rest of this from here, go ahead and pause the video and try to put 6 and 1/8 on the number line by yourselves and 2 and 1/12, and then come back and let's see how you did. All right, so first of all, you've got to figure out where 6 and 1/8 is on this number line. Well, it's greater than 6, but it's less than 7, so it comes between 6 and 7. If I divided this into 8 parts, the very first eighth is where I'm going to put 6 and 1/8. So you'll notice it's really close to 6. All right, so now 2 and 1/12. Well, it's more than 2, but it's less than 3. So it comes between 2 and 3. And a 12th is smaller than an eighth. So you're going to notice that my 2 and 1/12 is going to be closer to 2 than this 6 and 1/8 is closer to 6. So this is going to be, and I'm going to label it up here, 2 and 1/12. All right, so 2 and 1/12 is really close to 2. And 6 and 1/8 is really close to 6. So now I've got 6 minus 2, which is 4. Okay, why don't you try to do this one all by yourself and let's see how you do. Pause the video and try to do the whole thing by yourself. If you get stuck, you can always press play. Okay, so hopefully you got pretty far on this problem. Let's see how you did. All right, so I'm going to start with the number 3, and I'm going to go all the way to 6. So I've got 3, 4, 5, and 6. So let me go ahead and label these. 3 and 3/8 is going to come between 3 and 4. Well, 3 and 3/8 is really close to 3 1/2 or 3 4/8. So if I divided this into 4s so that I would have 8 parts here, 3 and 3/8 is going to be pretty close to 3 1/2. So I'm going to go ahead and put 3 and 3/8 right here. It's almost in the middle. And then 5 and 1/9, if I divide this into 9 parts, 5 and 1/9 is going to be the very first ninth. Now here's where you and I may have our numbers may differ. You may have said, well, 3 and 3/8 is closest to 3, and 5 and 1/9 is closer to 5. And then you could have said 3 plus 5 equals 8, and that would be correct. You also could have said, well, 3 and 3/8 is really close to 3 1/2, and 5 and 1/9 is close to 5. So you could have said it's about 8 1/2. I would have counted either of these answers correct, okay, because it's an estimate. 8 1/2 would be more accurate of an estimate, but 8 is still really close to the actual answer too. So I would have counted them both correct. All right, now we're going to estimate each sum or difference to the nearest whole or half by rounding. Explain your estimate using words or a number line. So basically we're doing the exact same thing, except you're going to notice they tried to make it a little bit trickier for us because they didn't give us the mixed numbers. We have to create the mixed numbers on our own, but that's okay. We can do this. All right, so first of all, I've got fifths. So I know 5/5 makes a whole. So out of 16, I can make 15 fifths because I know 5 times 3 is 15, and that's going to leave 1/5 left over. So 16 fifths is going to be the same thing as 3 and 1/5. And then let's go ahead and do 11 fourths. So let's see, 12 would be too much, so I'm going to have to go with 8 fourths, and then I'm going to have 3 fourths left over. So this will be 2 and 3 fourths. Okay, so let's go ahead and put these on a number line really quickly. All right, so I've got 2, 3, and 4. So 2 and 3/4 is going to be closer to 3. And 3 and 1/5, it's more than 3, so it's going to come between 3 and 4. So I've got 3 and 1/5. So both of these are going to round to 3. So 3 plus 3 would be 6. Okay? All right, let's try this one. So we've got 17 thirds. So I've got to think of all the 3's I can get out of 17. Well, I know I can get 5 times 3 is 15. So let's do 15 thirds, and then that's going to leave 2 thirds left over. So that means that 17 thirds is the same as 5 and 2, this should be thirds, 5 and 2 thirds. So I've got 5 and 2 thirds for my first one. and then 15/7. Well, I know 7 and 7 are 14, so let's do 14/7, and that's going to leave 1/7 left over. So this would be 2 and 1/7 minus 2 and 1/7. All right, so let's go ahead and draw our number line. Remember, we're subtracting this time. So I'm going to start with 2, and I'm going to go all the way to 6. So I've got 2, and I'm going to 6. So I've got 3, 4, and 5. 3, 4, and 5. So 5 and 2/3. Well, that's going to come between 5 and 6. It's going to be closer to 6, because if I divide this into thirds, I'm going to have 5 and 2/3. And then 2 and 1/7 is going to be down here, because 1/7 is just 1/7 greater than 2. So 2 and 1/7 is closer to 2. Now when you get to 5 and 2/3, you can say it's closer to 6, or you could also say it's closer to 6 and a half, or 5 and a half. I'm going to go with 6. So now I've got 6 minus 2, which is 4. So that would be my estimate. It estimates to about 4. All right, now let's do these tenths. I like tenths, they're easy. So we can say 50 tenths and 9 tenths. So that's going to give me 5 and 9 tenths. And then I can do 20 tenths. And I'm going to have 6 tenths left over. So that gives me 2 and 6 tenths. All right, so I'm adding these together. All right, so let's go ahead and draw our number line. So I'm going to start with 2 and go to 6, just like I did the one up here. So I can pretty much just copy this one. 2, 3, 4, 5. Why don't you pause the video and go ahead and put 5 and 9 tenths and 2 and 6 tenths on the number line and see if you can estimate the difference. So go ahead and pause the video and see how you do. All right, so hopefully you discovered that 5 and 9 tenths comes between 5 and 6, and 5 and 9 tenths would be way down here, because if I divided this into 10 parts and I counted over 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths, 8 tenths, 9 tenths, I would finally get way over here. And then when you get ready to do 2 and 6 tenths, that's going to come between 2 and 3. Well, 2 and 5 tenths would be right in the middle. So 2 and 6 tenths is just going to be a little bit closer to 3 than it is closer to 2. So I could say that this is, oh, this is an addition problem. I was going to subtract. I could say that this is closer to 2 and a half, or I could say it's closer to 3. And 5 and 9 tenths is definitely closer to 6. So you could say 6 plus 3, which equals 9. Or you could say 6 plus 2 and a half, which equals 8 and a half. I would count both of these right. The more accurate estimate would be 8 and a half, because it actually is closer to a half than it is closer to 3. But I would count 9 correct also. All right, Montoya's estimate for 8 and 5/8 minus 2 and 1/3 was 7. Julio's estimate was 6 and a half. Whose estimate do you think is closer to the actual difference? Well, we're going to have to see what we estimate this to be first of all. So let's go ahead and draw our number line. And we are starting with 2 and we're going to 9. So our numbers are going to have to be pretty close together. So I've got 3, 4, 5, 6, 7. Not going to work. I'm going to have to make it longer. All right, so this will be 3, 4, 5, 6, 7, 8, and then this can be 9. Sometimes you just have to do that. All right, so 3, 4, 5, 6, 7, 8. So let's start with 8 and 5/8. Well, I know 8 and 4/8 would be 1/2. So here's 8 and a half. And then 8 and 5/8 would be just to the right of that. I'm going to label it up here so it doesn't get all jumbled up. So 8 and 5/8 is right here. And then I've got 2 and 1/3. So if I divided this into thirds, I've got 2 and 1/3 right here. So 2 and 1/3 is closer to 2. 8 and 5/8, you could either say it's closer to 9 or you could say it's closer to 8 and a half. Let's start with 9. So if I said 8 and 5/8 is about 9, and I said 2 1/3 is about 2, then when I subtract, I would get 7. But if I said 8 5/8 is about 8 1/2, and I said 2 1/3 is about 2, then that's going to give me 6 1/2. So both of these estimates would be true, but the question is, whose estimate do you think is closer to the actual difference? Well, let's look at 8 5/8. Is it closer to 8 1/2, or is it closer to 9? Well, it's closer to 8 1/2. So that means that this estimate would be more accurate. So the question is, whose estimate do you think is closer to the actual difference? Well, we would say that Julio's estimate is closer because 8 5/8 is closer to 8 1/2 than it is to 9. So because 8 5/8 is closer to 8 1/2 than it is to 9, then when you round it to 8 1/2, you get a closer estimate. All right, so let's take a look at number 4. Use benchmark numbers or mental math to estimate the sum or the difference. So we're going to see if we can do this without a number line, okay? So I bet we can. All right, so let's think about 14 3/4. Well, 14 3/4 is about 15. And 29 11/12 is really close to 29 12/12, which would be 30. So that will give me an estimate of 45. All right, so let's take a look at 3 5/12. Well, 3 5/12 is really close to 3 6/12. And 3 6/12 is really close to 3 1/2. 54 5/8, well, 5/8 is really close to 4/8, which is a half. So this would be close to 54 1/2. So if I took 3 and 54 and added them together, then that would give me 57. And if I took 1/2 plus 1/2, that gives me 2 halves. So altogether, this would equal 58. All right, so let's try C. So I have 17 4/5. Well, 4/5 is almost a whole, so I'm going to say that this is about 18. And now I have 8 7/12. Well, 6/12 is 1/2. So this is really close to 8 1/2. So if I take 18 minus 8, that's going to give me 10. But then I still have to take away this half. How am I going to do that? What if I said 17 2/2 minus 8 1/2? So 17 minus 8 is 9, and 2/2 minus 1/2 is 1/2. If this doesn't make sense to you, don't panic. We're going to be doing this pretty soon the next couple of lessons, okay? So don't panic if this right here is a little bit confusing to you. All right, so let's make some mixed numbers here. All right, so I've got 65/8. Well, 8 times 8 is 64. So I know I can do 64/8 and 1/8, and that's going to give me 8 1/8. So let's go ahead and call this 8 1/8. And then when I do 37 sixes, well, I know 36 sixes will give me a whole number, and I'm going to have 1 6 left over. So I've got 6 and 1 6. So this is going to be pretty easy because 8 1/2 is really close to 8, and 6 and 1 6 is really close to 6. So this is going to estimate to be the number 2. All right, we did a lot of estimating in this lesson today, and we used a lot of different strategies. But basically what we're doing is you really have to have a clear mental picture of the fraction and understand what it is closest to. We mostly round it to the whole number. These halves may be a little bit confusing to you, and if it is confusing to you, just stick to the whole numbers. Your estimate will be a little bit less accurate, but it will still be a good estimate.